Hello friends, today I will discuss the numerical problems on mesh analysis. Let me take first problem. First question is find the current in 2 ohms resistor for the following circuit. So look at this. This is 10 volts connected in series with 1 ohm, and this is another 2 ohms, this is 6 ohms, this is 20 volts, and this is 3 ohms and 4 ohms, and this is 5 ohms, and this is 30 volts. So we want the current flowing in this 2 ohm resistor. So to solve this, we apply what is called Kirchhoff's voltage law, or that is also called loop method. So to apply the method, we have to redraw the circuit and then assign the loop currents and then give the polarities for the various elements in the circuit. So first redraw the circuit like this. Say look at this. This is the first loop, this is second loop, this is third loop. And we are assuming the loop 1 current is I1. So circulating in the clockwise direction. Similarly, loop 2 current we call as I2 and circulating in the anti-clockwise direction. And coming to the third loop, this is the third loop, and the third loop current we are assuming is as I3 and it is circulating in the clockwise direction. So after this, we have to assign the polarity for voltages across various elements as per the loop currents. So look at this. This is the first loop and the current direction we know. So in this current direction, passive element is 1 ohm here. The current entering the passive element, we treat this as positive and leaving that as negative. So plus minus. Similarly here this is 2 ohm resistor. Polarity is like this. The I1 enters the 2 ohm resistor, so that is plus, and leaving the 2 ohm, so that is negative. Same next, you have another 6 ohm resistor. So current I1 is entering 6 ohms here and then leaving. So entering we call that as positive terminal and the leaving as negative terminal. And this is the 10 volt supply and its polarity do not change. This is always negative terminal, this is always positive terminal. Next, go to the second loop. This is the second loop, and as per the second loop current I2, the polarity is like this. We start at this 20 volt supply. So this is negative terminal, this is positive terminal, 20 volts, it is as it is. Its polarity do not change with the direction of the current chosen. So whereas here 2 ohm resistor, the current I2 enters here, so we say that is positive terminal. Leaving the 2 ohms resistor is we take it as negative terminal. So here plus first, next negative. Next, same I2 flows through this 4 ohm resistor. First enters here, so that we call as positive terminal. And leaving the 4 ohm resistor, we call that as negative terminal. Then the same current I2 flows through the 3 ohm resistor also. So entering the 3 ohm resistor, we call as positive and leaving the 3 ohm resistor as negative like this. So we covered all the elements for loop 2. Similarly for loop 3, this is the loop 3 assumed direction. So we start at some point, say at 6 ohm resistor. So I3 enters 6 ohms here, so we call this is positive terminal, leaves the 6 ohm resistor here, so this we call as negative terminal. So next here I3 flows through this 4 ohm resistor. So first enters here, so we call that as positive terminal, and leaving the 4 ohm resistor we call as negative terminal. And the same I3 comes here and enters the 5 ohm resistor. So entering point we call as positive terminal and leaving terminal as negative terminal like this. And whereas the 30 volts supply polarity do not change. This is always negative and this is always positive. So we have completed redrawing the circuit and the assigning the loop currents and then assigning the polarity across various elements in the whole circuit. So once it is done, now we are ready to apply the KVL for each loop individually. So that is what we are writing here. Write the loop equations, applying KVL to loop 1. This is the loop 1. So you start at one point, say element voltage supply here. So in this direction, first getting negative, next positive. So we call this as voltage rise. So voltage rises we take as positive. So we write 10 here. Next, going from positive to negative, we call that as voltage drop. Voltage drop will get the negative terminal, negative value, negative sign. So that is 1 into current is I1, 1 I1 with negative sign. So we write minus I1. Next, here 2 ohm resistor. Here be careful. This is the common element for loop 1 and loop 2. So while writing the loop equation for loop 1, we assume that the I1 current or loop 1 current is more than the other current, means other loop current, that is I2. So here if you look at this current direction in the 2 ohm resistor, I1 is also flowing from top to bottom and I2 is also flowing from top to bottom in the 2 ohm resistor. So they get added. So we write I1 plus I2. So into 2. And with respect to loop 1 only, we have to give the sign for the voltage drop, voltage. So because with respect to loop 1, this is positive, this is negative. Going from positive to negative is called voltage drop. So we get minus 2 into I1 plus I2. Next, another element here, 6 ohms. So be careful here, this 6 ohms resistor is a common element between the loop 1 and loop 3. So we have to take this properly into account. So we have to assume the I1 is more than the I3. And if you look at this, I3 direction is opposite to the I1 direction. And similarly, here loop 2, first we write the loop 2 equation. So applying KVL to loop 2, then we write the equation like this. So first we start at 20 volts supply. So in the current direction assumed, right, first we are getting negative terminal, this is next positive terminal. The terminals of the voltage supply do not change with the assumed current direction. It is always same. So going from negative to positive, we call that as voltage rise. So that will get the positive sign. So we write here 20. Next, coming to the other terminal, other element here, 2 ohm resistor is there. This 2 ohm resistor, so getting here positive then negative. So we write, we say in the current direction, going from positive to negative, we call as voltage drop. Voltage drop will get the negative sign. So we write minus 2 into, what is the current that flows here? There are two currents flowing. One is I2, the other is I1. And incidentally here, both are moving are flowing in the same direction, so they should be added like this, I2 plus I1. Next, there is another element in the loop 2, that is 4 ohm resistor. In 4 ohm resistor, so look at this, positive terminal first and then negative terminal with respect to the I2 current. So going from positive to negative in the assumed current direction is called the voltage drop. So it will get the negative sign. So minus 4 into, what are the two currents that are flowing? One is I2, the other is I3. First we write I2, then we take the other current, that is I3. Here this I3 is flowing opposite to the direction of the I2. So we give the negative sign to the I3. So that is I2 minus I3. Next we have another element here. This is plus terminal, this is negative terminal. So going from positive to negative, we call voltage drop in the assumed current direction. So that is we write minus 3. What is the current flowing here? It is only I2 that is flowing. So we write simply 3 into I2 is equal to 0. Once we simplify this, so we get the equation like this, minus 2I1 minus 9I2 plus 4I3 is equal to minus 20, and we say this is equation 2. Earlier we had the equation like this. After simplification, we got minus 9I1 minus 2I2 plus 6I3 is equal to minus 10. That was loop 1 equation. This is loop 2 equation. Next, loop 3 equation, how to write? This is the loop 3. So we start at some point. This is the assumed current direction. So that is flowing in the clockwise direction. In that direction, when we start at one element, that is supply here, first we are getting negative, next positive, means voltage rise we get. So voltage rise will get the positive sign. So we write 30 here. Then next element in this assumed current direction is 6 ohms. So this 6 ohm resistor polarity is plus first, next negative with respect to I3. So this voltage across the 6 ohms will get the negative sign because it is a voltage drop. So minus 6 into what are the two currents that are flowing, because we are writing the loop 3 equation. So we assume the I3 is more. So we write first I3. And what is the other current that is flowing here? I1 is flowing, but that I1 is flowing opposite direction to that of the I3. So we write, we give the minus sign to that I1. So I3 minus I1 into 6. Next, you come to the another element here. So in the direction of I3. Here, this 4 ohm will have the positive terminal here. This is negative terminal with respect to the I3. So this will be treated going from positive to negative. We treat that as voltage drop. So it will get the negative sign. So minus 4. So what are the two currents that are flowing here? If you look at this, I2 is also flowing in the same direction as that of the I3. So first we write I3 plus I2. So next, you have another element here, 5 ohm resistor. So when we come here, we have the polarity here, plus first, next negative. So getting positive sign first, next negative in the assumed current direction means we treat that as voltage drop. So this 5 will get the minus sign first, minus 5. And what is the current that is flowing here? It is I3. So we write minus 5 I3 is equal to 0. So means we have written a loop equation for loop 3, similarly loop 2, similarly loop 1. So then you simplify this equation, then we get minus 15I3 plus 6I1 minus 4I2 is equal to minus 30. Next comes again simplify it, 6I1 minus 4I2 minus 15I3 is equal to minus 30. So then you simplify this loop 3 equation, we get 6I1 minus 4I2 minus 15I3 is equal to minus 30, and we say this is equation 3. So we have the 3 loop equations. So write these 3 equations in the matrix form like this. So we know this is loop 1, this is loop 2, and this is loop 3 equation. So once we write those equations in the matrix form, we get minus 9, minus 2, 6, minus 2, minus 9, 4, 6, minus 4, minus 15. Then this matrix becomes into I1, I2, I3 matrix is equal to, so minus 10, minus 20 and minus 30. So that is what we have written here, minus 10, minus 20, minus 30. So we know the crammers rule. So using crammers rule, we can calculate I1, I2 and I3. So to get the I1 value, so what we should do is write like this, I1 is equal to, you replace this first column matrix with the right hand side matrix. So that is replacing minus 9, minus 2, 6 with minus 10, minus 20, minus 30 like this. And keep this matrix as it is in the denominator like this. Then you simplify this. So once we simplify this, we get I1 current as 3.062 amperes. Next, similarly, we can calculate I2. How to calculate I2? I2 is nothing but I2 is equal to, we replace this second column with the right hand side matrix, that is minus 9, minus 2, 6, minus 10, minus 20, minus 30, 6, 4, minus 15 divided by the same matrix as we have done earlier, means the same matrix we use. So once we calculate that I2, means we get again I2 is equal to 3.06 amperes. Similarly, for I3 also what we do is we replace the third column with the right hand side matrix. So as usual we do the calculations. Once we do the calculations, we get I3 value as minus 3.33 amperes. So the question here is, what is the 2 ohms current? This is the 2 ohm resistor. What is the current flowing through the 2 ohm resistor? So if you look at this, what are the currents that are flowing? One is I1, the other is I2, and both are flowing in the same direction. So the 2 ohm resistor current, we call that as I1 plus I2. So 2 ohm current is I1 plus I2. We have calculated what is I1 and what is I2. So that is 3.06 plus 3.06. So once we add both, we get 6.12 amperes. So then, we have used the mesh analysis for this 3-loop circuit, and we obtained all currents in all loops, and we got the current flowing in the 2 ohm resistor.